Great. Hello, everyone, and welcome to Infrapioneer show. Today's episode guest, we have Joshua Miller from Kelar Pacific. Could you a little bit tell more about yourself and how did you end up doing on the VDC positions?
Sure, yeah. So I guess let me start with my background a little bit. So I was an electrician for about 10 years here in the United States. So when I graduated high school, it was during the middle of the recession here in the United States, so 2008. There weren't a lot of construction jobs, but I was really fortunate. I was able to get a position with an electrical company and started traveling all around the United States, working in electrical. And then I actually went to South America for several years. And when I came back, I met my wife, we got married, and I decided to go back to school. So I attended university for construction management. And while I was there, we were introduced to Autodesk Revit in one of our classes, and I just kind of fell in love with the software and the workflow of building a model and working through all of the problems in the computer. Because when I was out in the field, when we would encounter problems, it was up to us to figure it out. And that's really difficult when you're out there in the field doing heavy labor, manual labor. It's really hard to think through problems. And so a lot of times, we'd run into problems and, things just went awry. So that's kind of my first aha moment when I was in school and I saw the software. It was kind of an aha moment for me, I could work in this and solve the problems of the computer before we ever get to the field. Anyway, ended up going to work for a general contractor on the West Coast called Swinerton, and they were starting to work with mass timber structures, which is dual land beams, columns, CLT, which is relatively new in the United States. We've only been doing it for about 4 years now. And so I started the VDC program at Swinerton, designing these mass timber structures for fabrication. And then just recently moved to a new position at Kelar Pacific, which is like a BIM consulting and project services group. So still working with mass timber, but also helping train people in how to use BIM tools, creating VDC managers and BIM managers, and still working on projects. So that's kind of my background and how I ended up where I am today.
That's really cool. Just it was really interesting position title, the construction digitalization practice manager.
Yes, construction digital practice manager. Yeah.
So is it more like in like construction we have these terms like BIM coordinator? Is it more like who studies and understands different technologies and then teaches and applies them onto the project so everyone can benefit and utilize those different sets of tools?
Yeah, so I think one of the biggest problems that we have right now in the construction industry when it comes to technology implementation is that there are a lot of really intelligent and wonderful software developers that are producing tools that are very intricate and complex and so one of the biggest problems that we find in the construction industry is that the software and the tools are available and they've been available for some time, but construction firms have there's a large learning curve, which acts as a barrier for a lot of construction firms to implement the technology. So part of my position as construction practice manager is helping construction firms implement this new technology and come up with programs that optimize their work outcomes, so the profitability of the project. So it's about implementing the right technology and implementing it in the correct way to have the right outcomes. Because you can have really sophisticated software, but if you don't know how to use it or you don't know how to use it in the right way, it really doesn't benefit your business as much as learning how to optimize it.
Yeah, definitely. And I think what you said, that's completely true. I remembered one of I think it was a couple of weeks ago, we have these kind of surveyors CAD softwares. It's very engineered product made for engineers and no one else. So
Right.
then one of my foremen called me that, hey, I trying to now look the quality log points, how things are done. How can I make the measurement to the like design and then the log points? And then it was the command of like Control Shift R to
Yeah.
do it. And no wonder I found it. Okay, it's like the softwares are made usually based on the client feedback. They have just made new features, and now it's behind those commands. And it's kind of funny that it's really how to say, like when we are in technical industry, the requirements are really heavy, but then we also should be really focusing on the product design to how the user experience really goes, so the value and the benefit is then much more easy to gain.
Right, exactly.
What kind of inspirations did you have then that really got you into the VDC and all these products and tools?
Yeah, so I think my initial experience in school, first learning the software and having that construction experience, I think that was really the first time that I realized that BIM, building information modeling, would be so useful for construction managers and construction firms. I think at the time, this was about 5 or 6 years ago. At the time, at least in the United States, building information modeling was used primarily by engineers and architects, and construction firms didn't really know exactly how to implement it. They were doing BIM coordination, taking models and coordinating the models in a virtual space, but that's completely different from actually creating a building information model.
Yeah.
So I remember at school, a lot of my fellow students and classmates, they did not enjoy the class. They thought, well, this is a waste of time. When am I ever going to use this? But for me, I really saw usefulness. And then when I went on to work for general contractors, I think, working with the mass timber structural system was really what triggered the passion of it, because everything is prefabricated, right? So all of the whole structural system is pre-engineered and cut by a CNC machine in a factory, and then shipped to the job site and installed in place. Well, if it's cut wrong or fabricated wrong, you can't fix it in the field. You have to get a new piece from the factory, or you have to have a refabrication of the connection. So there's a lot of problems and a lot of costs that can be incurred if there's mistakes made in the prefabrication process. So I think that kind of triggered my passion in it, because I saw, well, here's a perfect way to implement BIM as a construction manager, because we were essentially taking the models from the architect and the engineer and developing it to a much higher level of detail and running all the coordination. And I just became very passionate about it, because it's really cool. It's fascinating to go from a computer to a CNC machine to the site. I think that process is what really triggered my passion for it.
Yeah, definitely. It was for me as well, like when I saw the first time machine control systems.
Yeah.
Like we had this BIM model that had the metadata and also the 3D surfaces, and then how it influenced the real practices. I think that's why the VDC industry and all the new tech tools and softwares, it's really interesting always to follow up to see what kind of new revelations or things people have found out using those.
Right, because when you're going from the BIM model to a machine, it's completely different, because the machine is completely dependent on your model, on the geometry, to make its cuts or do the fabrication. Whereas when you're developing a model just for construction, it's really the tradesperson that's, you're seeing your model or you're drawing and interpreting that in their head and then delivering a result. So I think there's a greater connection between the VDC engineer and the construction when it's prefabricated versus when it's built traditionally.
Yeah, definitely.
Yeah.
Just before I think the VDC itself is quite a big topic, but I would be really interested to hear more about the work processes and in your work, like in a nutshell, what kind of processes do you have when you are looking all these building information modeling and then the tools and building up the bridge between them and then getting it to the customers?
Sure. Yeah. So I'll just kind of walk you through a traditional workflow. So typically we start with either a Revit model or the construction document set, whichever is available, and we basically start from scratch. So a lot of people inherit the model from the architect or engineer, and they'll kind of build off of it. But I found that there's a lot of value, and to me that's kind of the difference between BIM and VDC, right? Starting from scratch is more of a VDC process, whereas working with a BIM model is more of a coordination process.
Yeah, definitely.
So as a VDC manager or engineer, I think it's important to start from scratch because VDC, virtual design and construction, is all about understanding how the design relates to construction. And so by starting from scratch, you begin to understand how the architect and engineer have gone through their process of putting this building together, and you start picking up on faults in the coordination process. Maybe what the architect drew and what the structural engineer drew don't exactly match up. And this is particularly apparent when you're working through the 2D details, right? Because a lot of those details are inherited from past projects, or they're part of the standard book of details that the architect and engineer has. So when you start to turn those 2D details into a BIM model, you start to see the holes in the design, where maybe the exterior wall system wasn't coordinated with the way that the engineer had laid out the floor slab. That's kind of an example. So that's kind of my process. Is I start at a very high level, looking through the architects and the engineers' drawings and their models, and trying to find the areas where maybe the architect and engineer glossed over the design or didn't have enough time to fully coordinate the design. So starting from the plan view, laying everything out in the project, and then when that's done, we typically call that an LOD 200 or 200 model. And then we take that LOD 250 model to an LOD 300 by incorporating a lot of those architectural and structural details as we turn those details into 3D BIM model. And then, during that process, we're writing RFIs, we're meeting with the architect and engineer, discussing some of the problems that we're seeing in the document set, revising some of those details. And then once we've moved through that process, we typically submit to the architect and engineer a set of drawings that we call an LOD 300 submittal. So this is confirming the layout is correct, confirming we usually document all of our RFIs on that submittal. So we'll document the RFIs that we submitted in our document set, in our model. And obviously, so we're using BIM 360, so it's Autodesk Construction Cloud, and this is making the process really, really simple. Because in BIM 360, you're basically, you have your Revit model, and you're putting the Revit model and all of your document sets on the cloud. And so you're able to communicate the issues and RFIs with your team, with the contractor, with the architect and engineer, all in a cloud-based environment. So it's very, very connected, right? So the architect can see an issue that you post on BIM 360 as soon as you post it. They'll see it in the cloud, and they can process that information, review it, and then respond to you. And you can elevate that issue to an RFI, and then you can essentially link it to your document set. So all of the RFIs and issues that you work through in your model and in your document set are already posted for you on this cloud-based environment. And so that makes submitting to the design team really simple with all of those RFIs logged. On a mass timber project, we'll write anywhere from 75 to 125 RFIs just for that scope of work. So it's a lot of work. Anyway, when we get that submittal back and approve the design team, that's when we start preparing the model for fabrication. So we'll take our LOD 300 model and we'll develop it to an LOD 400 model. And this includes all of the cuts in the wood for the connections.
Wow.
It includes the panelization of the floor slab. And then we export that from our Revit model and turn it into a file that can be read by the CNC. And that's when essentially it goes into production. You know, the model gets turned into real elements that come out of the CNC machine. And then during the construction phase, we'll produce another set of documents, like an installation and erection set of drawings for the people in the field. And that'll include temporary bracing. It'll include pick plans for all the individual elements and kind of define the construction sequence and tie in the construction schedule to the model. And then, you know, while we're doing that, we're also tracking the model, and we use Assemble Systems, which is another cloud-based software that tracks cost.
Symbol systems.
Yeah, Assemble Systems. ASSEMBLE.
Okay.
So Assemble Systems links to BIM 360, so it's linked to the cloud-based model, and what it does is it keeps track of all the quantities, and it'll update cost as you're developing the model. So every time you upload the model to Assemble, it'll tell you if the cost has changed, if something has been added to the design. So we're using the model to control cost, to control schedule, to control quality, and to mitigate the risk ultimately of all those items, right? So that's kind of the standard workflow, and
That's quite a loadful. There was a couple of things that I really want to dig deeper. There was the transition from less or more like dumb information from 250 to 300 to 400, and then the BIM 360 and the symbol systems. The LOD enrichment. I'm really curious of when you are enriching the data and adding more details. Are you using some kind of parametric softwares, or is it really just hard manual labor? Because that's
No. Yeah. So what we do is so most of the work is in Revit families. So we'll create parametric families. With mass timber design, you have these large beams and columns, but they need to be connected together with metal, right? There's steel plates, typically with bolts. So what we'll do is we'll create parametric Revit families that read the parameters from the elements that they're associated with. So let's take like a column base plate. So you're going from the glulam column to the concrete slab, and you have a knife plate, which is like this. So we'll create a Revit family that's parametric size of the column, and we'll include parameters like the tolerance or the constraints of the CNC tools. So the CNC tools have like a chainsaw tool that makes plunge cuts. It has a milling tool that's round and it cuts the wood. So we'll include constraints like the radius of the tools, and then we'll shape our steel and add extra length to the cut. And it's all parametric, right? So let's say you have a column that's 10 3/4 by 8 inches. You know, we'll have a base plate that's parametric to the size of that column. So the first step is creating the families and having all the parameters, and then we'll use Dynamo to place those families in the model. So Dynamo can go through and read instances of where you place columns and beams, and it knows where to place those individual connection elements with the scripts that we've written. And then what we'll do is we'll use Dynamo to fill out all those parameters, because, you know, in our Revit families, we have anywhere from 100 to 200 parameters for each family. And because that's kind of how we're mitigating the risk of the project, right? Because if you have a disconnection between your steel connection and your glulam column, that's where you have to refabricate. So we put all of those parameters in the families because yields the maximum result, right? And that's kind of the trick when you're going from different levels of detail. As a VDC manager engineer, you need to know where to put those parameters, because you want to simplify the model. You don't want to create extreme amounts of data for elements that aren't going to yield you any results, right? So in mass timber design, at least, the connections are where you want to put the most amount of data. So that's kind of the two methods that we're using. We're using the parametric families, we're using Dynamo to manipulate those parameters and automate the process of actually placing connections and things like that.
That's really cool. When it comes do you have own development team who is more focused on the parametric the script development and such, or is it you and your team who is also doing the application of how to apply these, also thinking and designing these parameters and how the flow should go so it stays effective and
yeah, so that's a good question. So we're actually using project management. It's another cloud-based solution. It's called Plannerly, and what Plannerly allows you to do is kind of split up the development of the model into different scopes of work and assign it to different members of your team. So what I'll typically do is I focus mostly on because I'm the manager. So I'll focus mostly on creating the families, putting in the parameters. I focus on looking at the details and working through kind of those high-level issues that we talked about, posting issues to the design team, working with them. And then I have a separate team that puts in all the structural elements. So they're actually doing the modeling, putting in the beams, the columns, the floor deck. And then I typically develop the Dynamo script. That's more of a high-level thing. But once those are developed, they can be reused for different projects. And then we have a separate team that works on integrating the architectural modeling. So we have one team that's doing the structural modeling, one team that's doing the architectural modeling. I'm doing the families and the Dynamo scripts and the issue tracking. And then at the end of the project, we have another process, which is the shop drawing. So we're taking the Revit elements, we're creating Revit assemblies, and then we're putting those individual assemblies on single sheets, putting dimensions on everything. And that's kind of a separate process. So we kind of split up our team that way, where we have different teams working on different parts of the model at the same time.
That's really cool. It's amazing to hear that companies have really put effort on building this workflow really on that level. Like for the infrastructure construction itself, it's still this Rhinoceros and Grasshopper or Dynamo scripts. It's still quite new thing. Like for the bridges, it's brand new, and for the earthwork, it's people have never heard of it. But it's I think we really need to, what you earlier thought about the building information modeling, and then from the scratch really building it up on that kind of BIM model that you can really utilize then all the other elements to really get the finished products and sets done. It's amazing to hear. Has it been a many years work to get this workflow flowing as you described?
It's taken several years to develop this, and it's an ongoing process. I think, and this is kind of an interesting point, because a lot of construction management firms will start a BIM department or a VDC department, and a lot of construction firms don't really know what the difference between BIM and VDC is, and then what they'll do is they'll only hire one or two VDC engineers to work for the department, and so it becomes really difficult, because if you're just one VDC engineer working on a project, all of those things I just described, you have to do all of them, and you have to do all of them concurrently, and it really becomes unmanageable. So I think it's important for construction firms to realize that VDC and BIM is becoming an increasingly complex operation. and that they really should devote more resources to building a strong department with multiple engineers that can split up the different tasks of VDC into different scopes. And so I think that's one of the biggest barriers to successfully implementing VDC in construction right now, at least in the United States, is that many of the high-level managers in an organization don't really understand what VDC is or what BIM is, and so they don't know how to implement a strong VDC program from a corporate level, right?
Definitely.
Yeah, so I think that's one of the things we need to work on in the construction industry right now, is just educating the decision makers in various companies of what VDC is, what BIM is, how complex it is, and then helping them tailor a management system from a corporate level that fills the needs. Because if you start a VDC program and you only hire 1 or 2 VDC engineers, they're going to get burned out. They're probably just quit your company and go work for companies. So in order to retain that talent, it's really important to build a system that, one, has multiple people, and two, has realistic work outcomes, right? So, because that's another problem, is I think people view VDC and BIM as like a magic solution that'll solve all the problems.
yeah, definitely. It's like a magic word.
When the BIM engineer or manager can't deliver, then there's some frustration, so.
Definitely. Do you want to set the record straight, the difference between VDC and the BIM for the listeners?
Yeah, so BIM, stands for Building Information Modeling, and that's the process of putting, of building a 3-dimensional model that's parametric, that contains information, related to the building. VDC stands for Virtual Design and Construction, and I guess, this is my own interpretation of what the definition is, but to me, virtual design and construction is more about integrating the design phase of the project and the construction phase of the project. So you're moving from the building has been in design to now you need to actually construct the building. And so VDC is more about filling in the information gaps between the initial BIM model and then developing a construction model. I think building information modeling is more about building a model, coordinating that model, and then making sure that the design expectations are met. A VDC engineer is still working with BIM, but they're using BIM to coordinate how is this actually going to be constructed. So they're putting in the constraints of the construction environment into the building information model, right? And those constraints could be anything. Like in the mass timber world, like we discussed, you have the constraints of the actual CNC machine. You have the constraints of what can actually be produced. So you have the constraints of how heavy things are, right? If an element of the building is too heavy to actually put in place, you can't actually wreck the building. You might have site constraints, right? You have to split up the model into different phases of work so that people can move around the site and actually install the building in sequence. So those are just some examples of the difference between BIM, which in my mind is just completely working in a digital space, in a virtual space, making sure everything works in the computer. And then VDC is more about, well, how do we take what's in the computer, put it in the real world?
Definitely, that was a really good clarification. And the VDC and BIM, I think now and even further in the future, they will get more and more cluttered. Like in Europe, we don't so much hear about the VDC other than VDC softwares and tools. But then when we talk about VDC, as you described, then we talk about BIM-based production, which is exactly that. But it's a good definition. I'm really curious. How do you see then, in terms of the VDC, what kind of future views days, like what we should be looking up?
Yeah, as far as the future, I think the future of BDC, I think it really lies in the work. So we need to have, I guess from my point of view, in the construction industry, we need to work on converting. Well, let me back up, because I think a lot of the software development virtual tools is going to displace some of the existing construction infrastructure in terms of, the more work that you do in the virtual space, the less work there is to do in the physical space. So what I think we're going to see is kind of a disruption of labor, kind of similar to what they saw in the manufacturing.
Yeah.
Right? So I think that there's going to be people that used to work in the field, or people with field experience, that are going to be somewhat displaced by the new technologies. But what's interesting is that the people that work in the field are ultimately the best people to work in VDC if they learn how to use BIM tools. Because who would be better than at turning a BIM model into a construction model than the people that know how to actually build a building?
Yeah, definitely.
So I see the future of VDC more from a labor perspective. I think there needs to be more emphasis on taking people from the field and putting them on a career track to becoming VDC engineers. So typically in construction firms, at least in the United States, someone working in the field, as a laborer, or let's take a carpenter for example. So a carpenter typically starts their career as an apprentice, then they become a journeyman. They might go on to be a foreman, managing their team. From foreman, they would go to superintendent, right? And then they might go to senior superintendent, or an operations manager at a corporate level, or a district level. So that's kind of the career trajectory currently of an apprentice carpenter. They might aspire to become a superintendent. Well, I think the future of the industry really comes into, let's take that career path and change it slightly so that you could progress from foreman to VDC engineer or VDC manager. Because it's kind of like construction scheduling, right? So in a lot of construction firms, they used to have a specific person that would just work on the construction schedule because it was seen as a computer technical task. But then a lot of construction firms saw, well, it's important to know how to use the tool on the computer, but it's even more important to know how to actually schedule them. And so what we see in the United States is that a lot of construction firms will have senior superintendents working on developing schedules, and then having superintendents working on actually managing the schedule on the construction site. So that's kind of how I see the future of VDC, is that construction firms will start taking superintendents, people that used to work in the field, and turning them into VDC engineers or VDC managers.
Yeah, that's definitely a good point. And I mean, it's already been seen that like if you think site foreman or that kind of role, the people usually what people expected from that role before was that you had been in the labor and you have been doing this job and had many years of experience on the projects. But now there's a growing demand of understanding the VDC tools and utilizing different equipments. And it's not just the foremen that they teach in the university, but now there's all these different new things that you should also have to be hired for sure. And it's really interesting. Like, while at the moment it's still this kind of like self-learning or learning from colleagues to gain this skill set. But I think in the future it will just focus on that. Okay, foreman's skill set will be having a little bit about IT, a little bit about the BIM, a little bit about the foremans, and then materials and so on. So it's really interesting to see how all these roles are getting more, how to say, more collaborative in the sense of like the language and understanding of different things is required now from everyone. Now it's not just, okay, surveyor is doing his job and if he's talking about surveying, I don't need to even understand. But now I really need to understand what he's talking and what things I can do to communicate back or to make decisions or better decisions regarding topics or issues. And it's really, really interesting to see where it leads. It's kind of like a crisis in that sense that the construction companies are only now, when the BIM and the VDC has been quite many tens of years in the market, now they start to realize that, holy shit, we need to have this and this and this, and we have been so traditional so far, and now we just have to change, otherwise we cannot compete.
Well, and you know what's going to happen is, and it's similar to the manufacturing, during the industrial age, is that the companies that are able to successfully implement the new tools and systems are the ones that are going to survive, and the construction companies that can't implement the new tools and systems just aren't going to make it. They're not going to be competitive, and so. Yeah, I mean, like what you said, it's kind of a crisis because construction firms that haven't implemented it yet are behind the ball, and there's all these construction companies that have been doing it for a long time, and now they're ahead, and so they have to play catch up in it this time.
Yeah, it's quite a high mountain to climb.
Right.
A little bit about the VDC engineer's job, as you have worked and seen a lot. What kind of advices would you give if people would be interested on getting this kind of work positions in the future? What kind of like skills or knowledge or experiences they should accumulate?
Yeah, so obviously they need to know how to use the software, and so and that more or less depends on what industry you're working in. It could also depend on what country you're in. So different countries have different softwares. I've seen. Here in the United States, the primary softwares would be Revit. So the Revit's kind of the foundation that you should start with as a VDC engineer. But what I found is with the software, at least, if you learn one BIM software, it's the principle of it, right? Different softwares might have different interfaces, different tools, but the principle of how to do it is the same across all softwares I've found. So obviously you need to know how to use the software, but like what we were talking about, you need to understand construction. You need to understand how things are actually built, put together, because if you're just building a model, you're not doing VDC, right? You need to build a model just as you would build it in real life, and that's the difference between BIM and VDC. So, as an aspiring VDC engineer, you need to know the software, but you also need to understand the construction. So, I'd recommend, either, and we live in a day and age where you can look up on YouTube or on Google anything. If you want to know how a concrete slab is placed, you can look up a video where someone's recorded people bending rebar, putting rebar in place, placing the concrete. You can learn anything online. You don't have to go to a construction site to learn how some of these things are done. There's also a lot of books, a lot of trade manuals that you could learn from. So that's what I'd recommend. The third thing I would recommend is once you've mastered the software, once you have kind of a basic understanding of the construction, is to get into actually programming. So learning Dynamo, learning computer language like Python or C# that has, that's kind of what Revit runs on, right? So understanding the computer program can help you go to the next level with the software tools, because then you can start doing things with the software that you can't do just through the user interface. That's kind of the three things I recommend: mastering the software, learning the construction, and then developing your software further by learning coding and tools like Dynamo.
Definitely, that's good. And I think it's quite underappreciated, understanding how to program or script even, because I think it's the more we go into the future, the more complex these softwares and tools will get. So understanding a little bit about the scripting, just the foundations, will give you a little bit of handway to understand, okay, what's happening here, and then starting to break it on from there.
Yeah, I mean, I think I can even think that in the future, and this is pretty far in the future, we're not even going to be drafting things. We're going to be programming the computer to create a model and input the data for us. And so it's going to be even more crucial to understand how the programs work, because I've been reading an interesting book lately. It's called Average is Over. It's by a American economist. But basically, he says that people that learn how to work with intelligent machines are going to be the industry leaders of the future. So learning how to work with intelligent machines, learning how the machine works is going to be crucial. So, moving into the future, it's going to be even more vital that people understand how the computer works and be able to interpret the data that the computer is giving to make informed decisions.
Definitely, that's a really good point. How then? What do you see like this kind of like common pitfalls or things that you should avoid or just skip regarding the VDC engineers' skill set that you should have?
Well, I think the biggest pitfall is not being able to focus on the right thing. So the industry right now is kind of saturated with so many different software tools and methodologies that you could get lost in just pursuing the next thing, right? The next new software. So I think the biggest pitfall is not understanding exactly what you're wanting to get out of the process. So, and you see this a lot with visualization and virtual reality, augmented reality. A lot of construction firms will go down that rabbit hole of virtual reality and augmented reality, when that's more of something that should be in the architect and engineer's wheelhouse, right? The architect should be the one managing the virtual reality and augmented reality, and construction firms should place that on the design firms, and the construction firms should focus more on the VD&C, of turning the model into something that can be built, because the architect is in charge of what the building looks like. The construction manager is in charge of building the building on time, on budget, and that's what VD&C is all about. So I think the biggest pitfall is you're in an industry and you get sidetracked by a new software that you think is just nifty, and it takes you off base of what you're actually trying to achieve with the software.
Yeah, definitely. It's yeah, I think every construction company who has got into this digital tools have experience with VR and AR, and the end result has been that it's nice to watch, but there's no value in it, at least yet.
Yeah, I mean, with augmented reality though, there is a bright future for construction firms, because imagine being on the job site, be able to see underground piping after the concrete slab has been poured. I mean, that's a lot of value right there.
Yeah.
So, I mean, it's sitting there.
Definitely, and I think that's a bit different thing as like all this laser scanning and drone point cloud production. I think all these scanning abilities will make this kind of like, so with the phone you can see where's the cables and such behind the wall or inside the ground. But then the AR itself, like I think it still requires more hardware technology to improve, because the location is crucial. Like otherwise, if it's just visual and it's not millimeter or centimeter accurate positions, then just having a checklist and marking which are done or such it doesn't like serve the audience on the need that they have.
Right. Yeah, I mean, one use case was, so several years ago I worked at a university where they did a lot of concrete cutting. So they would cut through the floor slab in order to install a drain or maybe we would install new piping. Well, they would pay thousands of dollars to have a service come out and scan through the floor to detect if there was piping in it, right? And this is pretty common. Imagine if you just had, your iPad and you had an AR application and you had the building information model. You could just look at the room and see if there was piping under the floor. Now, obviously, that it kind of depends too on how accurate the work was put into place. So that's another hurdle that would have to be overcome. Is we need to have technology that allows construction managers to actually confirm that piping and things have been placed where they were modeled. Because a lot of times, what happens, especially with MVP modeling, is that a really nice, highly detailed model was developed, but then when it gets put in the field, the people installing it just end up putting it wherever they want anyway. So
everyone knows the end result. It's never as designed, but close enough.
Right.
But
right,
yeah,
so
please say sorry.
We also need technology to confirm that things were placed according to the model, especially as models become more intricate and more detailed. We need that quality control of, like what you said. A pipe needs to be placed within a centimeter or millimeter of where it was designed to go. So.
Yeah, definitely, and it's interesting. Like I think the AR itself, I don't know how many tens years it needs, but has a lot of potential to bring all the data front of you instead of visiting the site office and reading papers or opening documents on computer. But you just could be on the site and make decisions and really focus on the work that is the most crucial to get the project done, and all this information management or such is not anymore a big problem. There's quite many many hoops to jump to, but I mean, yeah, the value is there in the end though.
Right.
Hey, I'm really curious also. I really want to hear your war stories, like the projects that you have implemented, this what you earlier spoke about, this VDC process, and what kind of projects have you done with those, and what kind of damn, I forgot the English name, like notices, like details, like how to say, the victory moment, so to say. Have you seen those projects?
You mean the weak point? You mean like you want to hear when things went wrong, or?
Well, yeah, both. Like, what kind of things that should have put more details or more attention to fix it, and then what kind of revelations have you had during those projects?
Yeah, so, gosh, I'm thinking back to, it was 3 years ago. I was working on a project. It was a community center, kind of like a gymnasium, right? It had a big basketball court and some weightlifting rooms, things like that. So one of the things that we noticed on that project was, let me back up a little bit again. So traditionally, like in a construction project, you have different scopes of work that are clearly delineated and split up between different parties that are supplying material. So, we were doing the mass timber scope of work, which includes all of the wood beams and columns and panels. And then there's another scope of work for the steel connection. And so we had contracted out with another party to do the steel detailing connections, and then we were doing the wood detailing connections. Well, we found that the level of error was just too high, because we were modeling our wood and then creating shop drawings, and then somebody else was modeling the steel and creating shop drawings. And then the way that we were quality controlling those two models was through paper. So the project manager the project manager was looking at the drawing of the wood and looking at the drawing of the steel and then saying, oh yeah, these work, these fit together. Well, that didn't work because we would manufacture the wood and they would manufacture the steel, and it just didn't match. So then we decided, well, we need to combine the activities. So if we're producing anything that's interacting with another piece, like if we're producing the wood and it's dependent on the steel, we need to model the wood and the steel and create the drawings from one model. We can't have two models and create drawings from each model and then compare the drawings. That takes too long and it's inefficient. So we're going to control that we're going to absorb the steel scope of work within the wood scope of work. We're going to produce all that, and then we're going to contract with the steel supplier so that if the steel supplier makes something wrong, we have the ultimate say over whether or not they need to remake that steel or not. Because the old way of working was that the steel supplier could just send whatever they wanted, and there was nobody that could reject the material because we didn't have the right contract. So I think that was the biggest lesson learned was you need to absorb. I think contractors need to start absorbing more scopes because it was traditionally if you look way back in time, the builder, there was a master builder, right, and they would do everything. They controlled everything. Well, as we move through history, that becomes more and more split up, and that's where you get a contractor, right? So a contractor takes a construction project and divides it up into hundreds of different scopes of work, and then gets 50 or so different subcontractors to sign a contract, and then those subcontractors sign contracts with material suppliers, and then the material supplier might sign a contract with the detailer, which is a model. Well, it's much more efficient if the contractor absorbs the scope of work and then contracts with their material supplier and just controls that process. And I think BIM and VDC is making that easier. So that was a big lesson learned from that project, was just if you really want to control quality, you need to just do it. If you're doing one scope that's dependent on another scope of work, you can use BIM and VDC tools to just absorb that information and ensure quality that way.
Definitely. That's the visualization and the combination models, like having different expertise to put all, like I think BIM 360 does that, right? Like there's many different designers and they all input or export their materials in one place, and then we can see how they fit together.
Right, yeah, and I think we need to move away from the shop drawings being the single source of truth, and start viewing the model as the source of truth, and the drawings are just an export from the model, right? So if you're able to visualize the model and coordinate the model in a virtual space, it becomes a much more simple process to approve the drawings, because you know that the drawings are coming from the model and you can trust the model. So I think that's another thing we're going to see in the future is companies moving away from the two-dimensional documents. Not that those will ever go away, because they're needed. They're needed contractually, right? It's more of a legal obligation, right? You submit something, it's approved, whatever.
Need to have something to rubber stamp.
Right. Because you can't rubber stamp a model, at least not yet. So, but if you know that the model is correct, then you know that the drawings are correct.
Yeah,
because
definitely.
The drawings are just an export from the model.
Out of curiosity, in United States, the clients, when they make the contract with the main contractor, is it usually the quality documents are the PDFs and the BIM models are the like visual aid, or are they equal?
They're not equal at all. So, at least right now, the models aren't really seen. At least from the construction standpoint, the models are not seen as a legitimate source of information. So everything is dependent on what's produced on the PDF, the two-dimensional document. So at least from a construction standpoint. So yeah, we're not quite there yet with I think where we need to be with building information modeling. So I don't know. Does that answer your question?
Yeah, definitely. It's just curious because, like, at least in Finland, we are now, well, not everyone, but our government's organization who builds most of the highways, and then a couple of municipalities are experimenting with this, that they put PDFs and the BIM models as equal importance. And then if there's any conflict between models and the PDFs, then the one which has more details will be the correct one. What usually is the BIM model itself, because there's much more rich details than what you get from PDFs. But of course, it's mainly for the earthwork. When it comes to the bridges or the like structures, tunnels and foundations or buildings, then it's still a strong PDF world. It was quite funny. Like there was one Alliance project, like big project that they built, and then there was the client who wanted the BIM, that hey, we need to implement BIM because we can give it to the citizens, they can see it and so on. And then the foreman went to the office and printed the 3D model on the paper and put it in there. There's your 3D. So it's quite funny, but yeah, I mean, I think all across the world we are getting there. It's just like the contracts are still quite traditional, and changing those is really slow progress. Like I think please say. Sorry.
Yeah, no, I was just gonna say I think as the construction industry moves towards productization, prefabrication, and automation, the models will become the governing legal document, because kind of as we discussed at the beginning of it, if you're going directly from a model to a machine, the model is the source of truth, because the machine doesn't read the drawing. So I think as we start to depend less and less on humans putting buildings together and more on machines, via prefabrication and automation, I think the model is going to be seen more as the source of truth, not the document.
Definitely. When it comes to the BIM and VDC, do you have any kind of book list or recommended sites, or where do you get your best ideas and things to implement in your own processes?
Yeah, so I really like, as far as a book list, that's a little bit more difficult. I think if you're just starting out, I would go with a book that has a detailed walkthrough. So there's Revit manuals that explain what the software is and go through the full ribbon, et cetera. But it's more useful to have a book that takes you through step-by-step building a project. So I would recommend that for a book. And there's lots of different books available like that. There's also a lot of YouTube videos, or not just YouTube, but there's a lot of online content where they'll walk you through a project step by step, and you actually go through working on a project. That's what I'd recommend for learning the software. As far as construction, there's so many books. I think the book that I've depended on the most is called Building Fundamentals. I don't know who the author is, but it's like a 1,000-page book that describes different building scopes of work and how they come together. But other than that, other than reading something, I would just go on and watch videos online of people actually installing steel, doing welds, installing piping, putting a boiler together. Because that's how you're going to learn how things are done, by watching people do it. There's a lot of resources online for that. And then for software, I like kind kind of like with Revit. So learning how to code, I would recommend getting a book that actually walks you through doing a project, like a software project. So there's a really good book that I learned Python with. It's called Python Crash Course. That's a really good one. Yeah, I'd say stay away from abstract books that explain in general terms what the software is and what it does, and go for more hands-on learning that actually teaches you how to do something with it.
Definitely.
Yeah.
That was really cool. Is there, like, around the globe any kind of mega projects that you would have wanted to be part of that really implemented the BIM and VDC on the ideal level, like some kind of like case study project?
No, I can't really think of one or recommend one. That'd be something to research about. Yeah, I haven't looked much into that, but yeah, I don't have any suggestions. I think for learning construction, the Freedom Tower in the United States in New York, the one that they built to commemorate the Twin Towers that were destroyed in 9/11. There's a lot of really good documentation about that project, and that's a really great way to learn some construction means and methods.
Okay, Freedom Tower. Need to put
Yeah.
on my watch list. It's like I really love those mega project documentaries and movies and such. Like I feel how well, of course, it's more dramatized and more made for movie people, but it's really interesting to see that how people have built these mega projects and how they have approached on those things. All the nuances and things that they had to like deal with before they then started building it. Just it's crazy. Maybe someday I will go to mega projects.
It's a really interesting project because they designed it so that if an airplane did hit it, that it would withstand the impact. So the concrete is really high strength, and it's really interesting because the tower is so tall. They actually had several instances where the concrete set in the tube as they were pumping it up the building, because the high strength concrete, because of the additives that they put in the concrete, the concrete set really fast. They had a very limited amount of time to pump the concrete up the tube and on the upper levels of the tower. So that's a really great project to just learn about construction means and methods, especially concrete and steel. I mean, it's just a fascinating project. So,
wow, that sounds amazing.
Yeah.
Let's try another question. If you would not went to the VDC or BIM, like if you would now wanted to change your like career direction somewhere else, what would be the second choice?
Yeah, I think, gosh, I'd love to teach. I'd love to be in university. It really could be anything. I love working with students and people. So I think I'd do something like that, more academic.
Definitely sharing the knowledge.
Sharing knowledge, but also doing research. I like to read a lot and just spend a lot of time reading and doing research. So I think that's what I would have done if I had done this career. But I don't know. I just kind of stumbled into this career path. It wasn't something that I set out to do, right? And I think that's something that, with emerging technologies and emerging industries, I think a lot of us find ourselves in that position.
Yeah.
Where we didn't set out to do it. We just kind of fell into it, right?
True.
Yeah.
Yeah, I mean, what I earlier spoke about, that there really isn't any formal school or education that gives you the skill set that VDC or BIM professionals use. It's just like you need to have good network of colleagues, and then you need to have a keen interest of understanding how these things works. in depth. That's the only way that I can figure out that how you can then really get the all skills required to really operate on the level.
Right. I mean, well, that's the same for any emerging, right? There. When Steve Jobs created Apple, there wasn't a school that taught how to create Apple.
That's true.
Yeah, it's similar to that, or like Elon Musk, with going to Mars. There's no school that teaches you how to. Well, I guess there might be schools. Yeah, rocket science. I think the first astronaut, or went to space, there wasn't any school that taught them how to do it. They have to figure it out, and they created a new branch of science. And so that's kind of what BDC is. It's a new branch of science almost. It's kind of like a science, like a building science.
Definitely. How about then learning? What kind of skills are you now picking up, or then advancing forward more in-depth topics?
Yeah, so right now I'm focusing mostly on the software. So learning how to code, making better software scripts to automate things in the model. But I'm also interested in learning new software. So kind of because I think a lot of people are looking for one software that's going to solve all of the problems. But I think what will work better is taking a lot of different pieces of software and finding ways that they can communicate and work with each other. And so I think there's a lot of value in learning a lot of different softwares. So you can learn how they might be used in conjunction. So those are kind of the two things that I'm focusing on right now, as far as learning, how to program and how to work with different software.
Definitely. Are you sticking with Python, or you are looking for C# and other scripting languages?
Yeah, right now I'm focused on Python and C#. Those are the two things, because primarily I'm working with Revit, and in Revit those are the two primary tools. But I also think that there's a lot of need for like SQL, like managing large databases, because a lot of the workflows right now are kind of dependent on Excel, which is basically just SQL with a human interface. So I think we'll learn how to become more efficient when we can learn how to integrate the software languages from the building information modeling world with the software languages like SQL from the data analysis world. So
definitely, and I think the construction industry itself, or the whole AEC industry, it's at the moment there's million of different products, and then there's the manual labor of bringing from another to there, and every company's the process like a software package is different. Like everyone has different combinations, so that's why the integrations and all these what you said about SQL and database management, and then of course data processing, I think those are something that I keep speaking in Finland on that topic, but I really haven't found the echo in the internet yet that people would be focusing on that. So it's nice to hear that you are also looking on that, because I think that's the big thing. Like I feel that in the future, maybe the software vendors itself don't develop all the integrations and automations, but then we as a customer, we will build the integrations, and then we can automate softwares that when it can automatically upload model in Revit, and then it takes quantities to this software and does tricks, and then returns something else, and like trying to automate the whole software processes. I think that's something that probably on commercial solutions we are not seeing in any near year.
Right.
How about then, as the last closing questions, if the audience itself wanted to reach out to you and talk to you, what would be the best way to get a hand on you?
Well, so you could call Keller Pacific. So if you go to kellerpacific.com, there's some contact information there. I'm also available pretty heavily on LinkedIn. So if you look me up on LinkedIn and we can message there. I'm reticent to hand out my email to anyone until we connect on LinkedIn, just because I'm trying to get away from email because I find it distracting. So I'm trying to be better at limiting my email interaction. So I would say, either call Keller Pacific and they could connect you with me, or connect with me on LinkedIn and we can message directly. I try to get on LinkedIn at least once a day, connect new connections and message with people, and that's how you and I got connected. So,
yeah, definitely. LinkedIn is a good way to meet new people.
Yeah, I also have a YouTube channel that I just started in December.
Please tell.
That's Construction Digital Practice with Joshua Miller. That's on YouTube. So right now it's just a lot of interviews, but this year I have a lot of plans to post more technical videos, walkthroughs and things like that. Exploring new technology. So look for me there. We also have some free videos on the Keller Pacific website that I've done in the past couple months. So some free technical training there.
Awesome. And I will be implementing for all the listeners the links on the description so you can find them there. Awesome. Okay. It was such a pleasure meeting you, Joshua.
Yeah, it's a pleasure meeting you.
The Infrapioneer Podcast, Infrastructure Construction, from the perspective of BIM specialists and on-site engineers.